How can it be possible that I can communicate with my smartphone practically everywhere? The signal travels better in the city or in the country? These and other questions we are going to answer in this video. But first, don't forget to hit the subscribe button, activate the bell to be notified of a new video, like, share and leave your comments below. Hello tech lovers, welcome to the second lesson of the course Architecture and General Principles of 4G Networks. If you have not seen the previous lesson, we have a link down below, or you can click in this card up here. The transmission power of a terminal, or a UV, in the 4G vocabulary is typically 0.2 watts or 200 milliwatts. The range with such power obviously depends on the situation. In other words, if I'm in the city, it's not the same range as if I'm in the country. But we can give as an order of magnitude a maximum range of several kilometers for a strength of 0.2 watts. That means if I'm in very far from the base station antenna, I'm not going to be able to have my communication. Or in other words, I'm not going to have my access to mobile internet. What the operator will do is deploy base stations as regularly as possible in order to cover the territory, in a way that wherever I am, I'm less than a few kilometers from the base station. Of course, in practice, this isn't true. There are wide areas where there is no coverage, but having base stations everywhere is the ultimate objective. Now the question is, how to know if I have access to the network, whether I'm actually close enough to a base station to have access to mobile internet? For that, each base station periodically broadcasts a signal called beacon channel. This beacon channel first enables indication of the presence of the network, and it gives the characteristics of the network, among which the identity of the operator. This way, my terminal will try to listen for my operator's base station, and not that of the competitor. All terminals measure the strength with which they receive this beacon channel. We have made a simple example on the drawing. The transmission of the beacon channel is symbolized by these concentric arcs. When the person is close to the base station, the signal received is very strong, as you can see in this figure. This corresponds to having a lot of bars on the terminal's display. The further you are from the base station, the fewer bars you have, as you can see here. When the terminal doesn't detect any signal, well, then it displays this message: no network. And logically, there aren't any bars, as you can see in this last one. Let's get back to the grade of base stations over the territory. Here, we have an example around the city. The scale is 5 kilometers. When there is a 1, that means that there is one base station, and we can see that the base stations are relatively regularly placed to provide coverage. But if we look at an area around the city. The city is about here. We see that. In the area surrounding the city, the base stations are a little more densely arranged than in the previous case. And if we look at the downtown, it's the following slide. We have the city. The scale is 2 kilometers. This image in the right. Base stations are densely arranged, and when we have the number 2, that means there are 2 base stations not too far away. But what does that mean after all? That means that the operator, when it has a lot of customers to serve, will deploy a large number of base stations. And the area covered by the base station is called cell, and the cell is smaller. In suburban zone, it will be a little larger, and in the rural zone, it will be much larger, from several kilometers up to a radius of 10 kilometers. Wow! The concept of cell consists of dividing the territory into cells, each one served by one base station. For people who can access the network, there are terminals to the base stations, and the signal is then sent into the network. Ideally, the division into cells is imperceptible to the user. That's the objective. Passing from one cell to another when the user moves should be completely invisible. What we could show with a small mathematical model is that the capacity of a cell, that is, the number of megabits per second that one can transmit by cell, does not depend on the size of the cell. In the urban areas, there is a high density of users. In this case, the base stations are deployed much more densely because there is a problem of capacity. The operator should deploy enough base stations so that the capacity in megabits per kilometer quarter is superior to the traffic created by the customers. In rural areas, there is low density of users, so the operator will try to just ensure the coverage. The operator should deploy enough base stations so that at very point of the territory, a terminal is under the range of a base station and can be connected. Hello tech lovers, thanks for watching, and don't forget to like and share the video. I am launching one lesson per week, so it's important that you subscribe and activate the bell to be notified when I upload a new video. Stay home, wash your hands, and take care.